your recording so that if you missed this example, then you can do that. You can look at it later. So where we ended at last class, one of the examples that we did was that example with a solar panel. And we figured out theta was 71.4. That was pretty good, but not perfect, right? So then we proposed this question at the bottom. What if we put x there? Could we find that length perfectly so that we can make it exactly 70? And that's what we're going to look at today, is how we can use tangents to calculate lengths on the sides of triangles so we could figure that out perfectly. So here we want to determine the length of xy. Xy goes on this side. That's opposite the vertex z. So we'd put a little z there because that would be how to properly label it. And what do we know about tangent? Tangent is the opposite side over the adjacent side. That's the definition of tangent. So that's a definition that's not on your formula sheet. You have to know that one. And so for 70 degrees, if I wrote tan of 70 degrees, well, opposite of 70 is something I don't know. That's z. And adjacent to 70, now the question is, this side here, which would be little y, is that the adjacent side, or is the 5 the adjacent side? And how would you know? Well, here's our 90 degree, right? What's the side opposite the 90 degree called? That's our hypotenuse. So the adjacent side to 70 is the 5. If we pull out our calculator and we type tan of 70, again, your calculator has it memorized that if you had a 70 degree angle, the ratio would be 2.747. That's what the ratio would be. So if we go back to our example here, we know that the ratio of z over 5 has to equal 2.7. Now algebraically, what would you do to get z all by itself? Multiply both sides by 5. Multiply by 5. And we get 13.7 to the nearest tenth. Is equal to z. One of the things we're going to do more and more in a pre-calculus course is we're not going to go to decimals in the middle of our question. We're going to have this question, again, I'll do it again here in green. Tan of 70 degrees is equal to z over 5. If I wanted to get z all by itself, I could do that by multiplying both sides by 5. If I did that right away, 5s would cancel out, and I would get z equals to 5 times tan of 70. And if you just write two things right beside each other, that means multiplication. You don't need to put an x in there. If you like to put a little dot in there, you can, but you don't need to do that either. And you can type this whole thing into your calculator all at once. 5, 10, 70. And you get the exact same answer.